Good day for total everyone. We come from Group A. Our word to industry visit is BBRAUN Medical Technology Company. Before we start our presentation, let me introduce my group member. Here is the list of group members. Our group consists of 4 persons. First one, Dalila BATRISYIA with matrix number DN240120. Second one, MAISARAH SHAHIDA with matrix number DN240170. Next one is IMANINA with matrix number DN240132. Last one is me, CHENG, with matrix number AN240175.
Next, I will continue the introduction part. BBRAUN is a global medical technology company that has been established for over 180 years. They have been operating in Malaysia since 1972 with a strong focus on medical devices and sterilization technologies. BBRAUN also have a core activity which is include the production of medical devices and ethylene oxide sterilization. Other than that, BBRAUN ensure compliance with international standard and focus heavily on quality, safety, and sustainability in all their operation. BBRAUN medical industry values and committed to a patient safety and product quality. They prioritize employee health and well-being, practice environmental responsibility, and also believe in continuous improvement and innovation. This commitment to excellence makes BBRAUN a key player in the medical technology industry, and why we choose this as our company for interview.
This diagram is the origin overall operation of BBRAUN Medical Technology Company, but this is hard to understand and hard to break down for us to understand, so I already simplify it. So I already use the process block diagram to simplify origin operation diagram for BBRAUN Medical Technology Company. Here is the process block diagram for ethylene oxide, which is known as EO, sterilizing process used for industry applications. Let me explain this. Raw water is first purified in a water treatment unit and then sent to a steam boiler to produce steam, which controls heating and humidity in the system. Liquid EO is fed into a vaporizer and heated by a heat skid using steam to maintain a temperature of about 56 degrees Celsius. This allows EO to vaporize safely and effectively. Nitrogen gas will be acted as an inert carrier gas while compressed air supports proper mixing and flow control. The EO vapor mixture is then directed into the sterilization chamber to eliminate microorganisms. After completing the sterilization cycle, the product are transferred to a weighing scale for quantity verification before being released as the final product, which is known as cannulas. If any items fail to inspection, they are returned to the loading area and repacked if necessary. Then it will be reprocessed in the sterilizing chamber. Here's the overall operation for this sterilization process for EO. So, I already highlight the wastewater treatment units of BBRAUN Medical Technology Company because this already achieved with our UTHM mission, which is promoting sustainability. Here is the process flow diagram for wastewater collection and neutralization system of BBRAUN Medical Technology Company. Let me explain this. Wastewater generated from the production process is collected in the waste collection tank by monitoring levels. Then is transferred by wastewater transfer pump and stroke B to the neutralization line. At the same time, boiler brought down water and city water are sent to a boiler cooling tank and flow to a boiler collection tank where wastewater is accumulated and will be pumped using another set of transfer pumps A/B. All wastewater streams are directed into the neutralization tank. That pH is controlled by chemicals from the acidate tank. via an acid dosing pump, and from the SMBS day tank via an SMBS dosing pump to chemical treatment. The neutralization tank is equipped with level indicators to ensure safe operation. Once the wastewater is properly treated, it is safely released through the final discharge line according to the environmental rules.
Hello everyone, my name is MAISARAH binti SHAHIDA with matrix number DN240170. So we're gonna go to equipment part, which is firstly is sterilizing chamber pressure vessel. Sterilizing chamber is a customized stainless steel pressure vessel designed to safely contain the ethylene oxide sterilization process. It is equipped with sensor to monitor pressure, humidity, and temperature. This system operates at atmospheric pressure before creating a deep vacuum below 1000 millibars to ensure effective gas penetration. Humidity and temperature maintained at around 56 degrees Celsius are critical for sterilization efficiency. Operating under vacuum rather than high pressure significantly reduces the risk of leaks or explosion. So we move to another equipment, which is water treatment. Water treatment is essential because steam is used for both humidification and jacket heating. Municipal water does not meet industrial standards due to high chloride levels, conductivity, and suspend solid. Therefore, the water passes through multiple treatment stages, including carbon and sterile filtration, before being converted into steam. This ensures pure steam delivery, prevents corrosion and scale build-up, protects stainless steel equipment, and enables effective ETO sterilization. So next, we move to another equipment, which is steam boiler. In an ethylene oxide sterilization plant, the steam boiler converts treated water into high quality steam for humidification and heating. Steam quality is critical. Saturated steam provides efficient heat transfer and moisture to activate the ethylene oxide gas. Superheated steam is avoided as it behaves like dry gas and reduces effectiveness. Clean steam produced from high purity water in stainless steel boilers ensures safe, reliable, and effective sterilization. So next equipment is heating skid. Ethylene oxide sterilization is a low temperature process where maintaining 56 degrees Celsius is critical. The heating skid circulates hot water or steam through the chamber jacket to keep the temperature stable. Any temperature fluctuation can directly reduce sterilization efficiency. Therefore, the heating skid ensures precise and continuous temperature control throughout the entire cycle. Next is weighing scale. Ethylene oxide is toxic and highly flammable, so precise dosing is critical. Ethylene oxide is supplied in drums and injected based on weight measurement using a calibrated weighing scale. By comparing the drum weight before and after injection, operators ensure the correct dose, about 40 kilograms per cycle, is delivered into the chamber. This weight-based control is the primary method for ensuring safe and effective ethylene oxide concentration. Next is vaporizer. Ethylene oxide is stored as a pressurized liquid but must enter the chamber as a gas. A vaporizer uses hot water to rapidly heat the liquid ethylene oxide, converting it into gas before injection. This ensures effective penetration and successful sterilization. Next is pump. Vacuum pumps are critical to ethylene oxide sterilization. They create a deep vacuum to remove all air before gas injection, ensuring full penetration. After sterilization, the pumps purge and aerate the chamber to remove ethylene oxide residue. Regular maintenance ensures reliable and safe operation.
Okay, so now let's take a look on the OSH practices which implemented inside the BBRAUN medical industry. Okay, occupational safety and health, or OSH, refers to the policies, system, and practices implemented to protect workers from injuries, illnesses, and unsafe working conditions. In industrial environments, especially chemical-based industry, OSH is essential because workers are exposed to hazardous substances, high-pressure system, machinery, and confined spaces. At BBRAUN Medical Industry, OSH plays a critical role due to the use of ethylene oxide in the sterilization process, which is toxic, flammable, and carcinogenic. Therefore, strict safety management systems are required to protect workers, products, and the surrounding environment. Okay, so now let's move to the ISO standard. So first is ISO 14001, which is an international standards that provides a framework for establishing environmental management system. At BBRAUN, ISO 14001 is to ensure that environmental aspects such as chemical waste disposal, ethylene oxide emissions, and wastewater discharge are properly controlled. Hazardous waste like ethylene oxide must be handled using strict disposal protocols to prevent pollution. Emission monitoring and wastewater treatments are also implemented to ensure compliance with environmental regulations and to reduce environmental impact. So next is ISO 45001, which is the International Standards for Occupational Health and Safety Management System. It focuses on proactive risk management, leadership involvement, and worker participation to prevent work-related injuries and illness. The standards follows the PDCA, which is plan, do, check, and act cycle, where hazards are identified, control measures are implemented, performance is monitored, and improvements are made continuously. By implementing ISO 45001, BBRAUN ensures a systematic and continuous improvement approach to workplace safety. So next, we move to ISO 10993 Part 7, which is ethylene oxide residue control. So ISO 109937 is a standard that specifies acceptable limits for ethylene oxide residues remaining on the medical devices after sterilization. This standard is crucial because ethylene oxide is highly toxic, flammable, and classified as a Class 1 human carcinogen. BBRAUN used these standards to validate its sterilization and aeration processes, ensuring that residual ethylene oxide levels are reduced to safe limits before products are released for use. So next is ISO 1135/2014, which is for the ethylene oxide sterilization process. So ISO 1135 regulates the use of ethylene oxide for sterilizing medical devices. The standard specifies requirements for developing and validating and routinely controlling the ethylene oxide sterilization process. Critical parameters such as temperature, humidity, pressure, gas concentration, and exposure time must be monitored continuously. Compliance with this standard ensures effective sterilization while maintaining safety for both workers and patients. So next is ISO 11607 Part 1 and 2. It is focuses for the packaging for sterilized device. So ISO 11607 focuses on packaging requirements for terminally sterilized medical devices. Part 1 specifies requirements for packaging materials and sterile barrier system, while Part 2 focuses on validating forming, sealing, and assembly process. At BBRAUN, compliance with these standards ensures that packaging maintains sterility and prevents contamination until the medical device is used. So next, we focus on the ASTM F2096, which is for the bubble leak test. So ASTM F2096 is a standard test method which known as the bubble leak test. It is used to detect gross leaks in medical device packaging by pressurizing the package and submerging it in the water. The presence of bubbles indicate a leak in the packaging, which could compromise the sterility, and this test ensures packaging integrity and protects patient safety. So next is ASTM F1929, which is for the dye leak test. In STM F1929 is the dye leak test method used to detect seal leaks in porous medical packaging. A colored dye solution is applied to the packaging, and if a leak is present, the dye penetrates the seal and reveals the defect. This test is effective for identifying small leaks that may not be detected by visual inspection alone. Okay, so now let's take a look on the OSH practices which implemented inside the BBRAUN medical industry. Okay, occupational safety and health, or OSH, refers to the policies, system, and practices implemented to protect workers from injuries, illnesses, and unsafe working conditions. In industrial environments, especially chemical-based industry, OSH is essential because workers are exposed to hazardous substances, high-pressure system, machinery, and confined spaces. At BBRAUN medical industry, OSH plays a critical role due to the use of ethylene oxide in the sterilization process, which is toxic, flammable, and carcinogenic. Therefore, strict safety management systems are required to protect workers, products, and the surrounding environment. Okay, now we will focus on daily operational controls. Daily operational controls focus on real-time risk prevention, whereas the operator perform pre-operation checks on sterilization chambers, vacuum pumps, sensor, alarms, and interlocks. The continuous ethylene oxide gas monitoring system are used to detect leaks, and alarms are activated if the exposure limits are exceeded. PPE such as gloves, goggles, respirators, and anti-static shoes are mandatory for workers handling the ethylene oxide. So next, we talk about the monthly performance monitoring. Monthly performance monitoring ensures that safety system remains effective and compliant. The safety committee reviews ethylene oxide exposure records, near-miss incidents, and maintenance reports. Hazard assessments are updated, and safety equipment such as fire extinguisher, emergency showers, ventilation systems, and gas scrubbers are inspected regularly. And lastly is yearly management review. Yearly management review focus on long-term safety planning and compliance. Internal and external audits are conducted for ISO 45001, ISO 1135, and ISO 14001. Emergency drills such as fire evacuation and ethylene oxide gas leak simulations are performed. Workers that are exposed to ethylene oxide needs to undergo annual medical checkups, and SOPs are updated to reflect improvement in safety practices. Thank you, that's all from me. I will pass to the next presenter.
For this section, I will discuss the main problem identified at BBRAUN medical industry and how they are managed. The challenges are grouped into 4 categories, which is production, technical, environmental, and safety-related challenge. First, I will explain the production-related challenge, which is the first is EO exposure control during sterilization. Because BBRAUN produce medical devices, it is required very precise ethylene oxide sterilization condition. This company control exposure time, temperature, humidity, and gas concentration to avoid unsafe residual level. And from our point of view, we suggest reviewing cycle data regularly to improve efficiency and safety. Other challenge that this company face is nitrogen supply change management. They need a continuous nitrogen supply as is vital for EO sterilization. Disruption can lead to production downtime. What BBRAUN did is manage this by using early supplier notification and also internal nitrogen storage as backup. And for our suggestion, it is to monitor nitrogen usage and prepare risk assessment for supply disruption. Next, I will continue to the technical challenge faced during plant operation in BBRAUN. First is safe handling of ethylene oxide. Because ethylene oxide is a flammable and
poses fire and also have explosion risk. This company use nitrogen blanketing and strict concentration control to reduce the risk. From our sides, we recommend regular inspection of the nitrogen blanketing system. Next, I will continue the safety challenge that face in BRAUN industry. First of all is ethylene oxide leak detection and emergency response. As we all know, EO is a hazardous and carcinogen gas. So, BRAUN has applied a 24-hour leak detection system with alarm and evacuation system. But from our side, we suggest personal EO monitors on each workers and also regular emergency drill to enhance safety so they will be prepared on what to do if there's a leak. Next is environmental challenge. We focus on water quality management as wastewater treatment required before discharge and risk of equipment corrosion and pollution. From the company, they've applied multi-stage treatment, carbon, sterile, and 5-micron filter. This already filter a lot of things. Other than that, they also do a continuous monitoring of conductivity, metal content, and pH neutralization. But from our student suggestion, we suggest to enhance monitoring with automated alerts. They also conduct statistical analysis of water quality trends. That's all from my side.